own geological survey. You knew? All right, okay. So we do have our own state geological survey. Not every state has a geological survey, but about 38 do. And most of the geologists that I work with are located in Columbia, but 2 of us are down at the coast of Charleston. Myself and my supervisor, Will Dorff, who's actually responsible for this geology map right here, hanging on the wall. He's also done a lot of work down here in the East Basin and on Edisto Island. But today, I'm going to be talking with you about coastal geomorphology from Charleston to Edisto. So I'm hoping to speak for about 45 minutes probably, and then we'll have plenty of time for questions. I also brought a core with me that was collected out at Pocky Island that I can show y'all. So we'll cover quite a lot, starting with the general geology of the area and then moving more into the specific work that we've been doing out at Botany Bay. So first of all, what is geomorphology? That is kind of a strange term that a lot of people are maybe unfamiliar with. It is, well, if you break it down into sort of the substructure of the word, it is the study of shapes or forms, landforms on the Earth's surface. So there are different kinds of geomorphology. There are people who study glacial geomorphology. So if any of y'all have ever been up to Maine or Canadian Maritimes, the landscape up in that area has been shaped by glaciers. You see a lot of U-shaped valleys. You see a lot of giant boulders that are out in the middle of a field, sort of inexplicably, that have been dropped by glaciers. So that's a landscape that's been formed by glacial geomorphology. Also, fluvial geomorphology is another aspect of part of the field. And then, of course, what we're going to talk about today and what we're really concerned with here in the Low Country is coastal geomorphology. So studying the landforms of the coast, our barrier islands, our inlets, our dunes, and how they form, how they change, because as we know, they are extremely dynamic. And I am a geologist, so if any of y'all had a geology class once upon a time, I've got to take you back into geologic time a little bit. I'm just obligated to do it. Because what we're working with here on the coast, what we stand on, this is geologically very, very young material. So the age of the Earth, if you can read it here on this graphic that takes us from present all the way back to the origin of the universe. We're not going to go back quite that far, but the origin of the Earth about 4.5 billion years ago. And you can see this is a great graphic taking us forward into present time when today's barrier islands formed. Another way that I like to think about it is if you think about all this time here, 4.5 billion years to present as the length between my 2 arms here, so this is all 4.5 billion years, if this is the very beginning of Earth here, and this is present day, then all of our modern sort of human life would fit in the very end of my right fingertip, on my middle finger here. So we are at the very, very tip of geologic time. The Earth has had supercontinents. We had Pangea about 250 million years ago. And there are geologists who study very, very old rocks that are 500,000 to 1 million years old. So we're not going to talk about anything quite that old today, but I did want to kind of give you appreciation of how old the Earth is and how young a lot of the deposits we're going to be talking about today are. So the Earth has changed significantly throughout this long, long, expansive time period. Our sea levels have also changed over time. So thinking back about 100 million years, so this was a period of time known as the Cretaceous. Some of y'all may have heard of the Cretaceous. End of the dinosaurs, about 65 million years ago. But at that point in time, you can see here the Cretaceous in this black hatch line here. Sea levels would actually have been right around where Columbia, South Carolina is today. So right around where the fall line is. And Earth was much hotter at this time period. We had no polar ice anywhere. Carbon dioxide levels were over twice what they currently are today. So very, very hot environmentally. And then as we move forward toward present day, you can see that that shoreline has continued to change. We actually had, so during an epoch of geologic time called the Pleistocene, about 2.6 million years to around 11,000 years ago, we entered into our ice ages. We had our last glacial maximum, so our last big ice age around 20,000 years ago. And the glacial ice sheet came as far south as right around New Jersey. And as you can imagine, that ice sheet was massive. And so it tied up a lot of water, and water levels were actually a whole lot lower. So at this period of time, around 20,000 years ago, the shoreline was way out on what we call the continental shelf right now. So all of that would have been exposed. As that ice sheet began to retreat, those waters started to rise. And we think that sea levels reached their near present levels around 5,000 to 4,500 years ago. And so that's consistent with some of the age dating that we've done on barrier islands like Kiowa, Capers Island, Dewey's Island, Folly, is that they're all, we think, several thousand years old. So we see evidence of this, we call it a low stand. So when sea levels were lower, when the shoreline was way out on the shelf, and some of the features that are on the shelf. So this is some mapping that's been done offshore. Here's Charleston right here. Here we are right here on Edisto, and you can see there's deltaic features offshore. There's big deposits of sand in certain places. This is the shelf break right here. So I don't know if anybody here has been out to the shelf break. That's where most people go if they're going to go deep sea fishing around here. It's about 60 miles offshore of Charleston, but water levels would have been way out along here during the last glacial maximum. We also see evidence in some of the data collected by different institutions like NOAA, College of Charleston, Coastal Carolina University. We also see paleo channels. So when those sea levels were lower, we had channels that extended all the way onto this continental shelf, and those were carving down into the stratigraphy or the underlying geology. So we see evidence of channels offshore. Sometimes we see old meanders right in here where sea levels rose so fast that they covered those features quickly, and those were actually preserved in the superficial geology, which is pretty remarkable. And then also, this is some work that was done by Scott Harris and others at the College of Charleston in 2013. These data show that these are actually iceberg scours. So there were icebergs that were this far south that scoured along the seafloor, and some of that was preserved as well. So,
do they know? Do they know why something would get covered up? And what event made it happen so it just covered it up so fast?
Just the sea level rise. The sea levels.
So temperature changed in the earth at some point
Yes.
pretty quickly.
Yes.
Then, boom.
Yeah, and during the Pleistocene, there were multiple glacial maxima, and then, so we had glacial periods, and then we have interglacial periods. Right now, we're actually in an interglacial. So during interglacials, we don't have ice sheets coming as far south, and conditions are generally more temperate, a little bit warmer, but there is a cyclicity to it. We actually don't know how many glacial episodes there were, because like you saw with the picture of glacial geomorphology, it is very destructive. So a big glacial ice sheet comes in, sometimes it can completely remove what another ice sheet had deposited and rework it. So it's difficult to really pick out how many there were, but we do have good evidence of the last glacial maximum. But yes, and teasing out how quickly that sea level, that water rose is challenging, definitely for geologists, because we know it happened in about a 15,000 year period, but it was likely a higher rate at certain times during that past time. Fast enough to cover and preserve features like this.
As I say, it must have been pretty fast. You know?
Yes.
Wake up one morning and go, oh, I don't have any more anymore.
Yeah, this was quick. What happened here? And you can see in the little red box right here. It's offshore here, and yeah, I can probably tell you exactly where, but I need to probably look at the map a little closer. But yeah, the preservation is pretty amazing in some of those. maps. So another way of looking at this, so starting, this is part of the geologic time scale. This is an era called the Cenozoic, so this is our modern time from the end of the Mesozoic, so end of the dinosaurs to present day. And I'm just gonna flip forward through these slides and it'll show you how, just keep an eye on South Carolina right here, and it'll show you how the water came in to around the fall line, right around where Columbia is here, during the Eocene. And this was when a lot of our carbonate rocks, a lot of the, if any of y'all have heard of the Santee limestone, that's when, this is the epoch of time when the Santee limestone was being deposited. So we have warm, shallow seas. Moving through time, you can see during the Oligocene, so this is 23 to 33 million years ago, we still had a big part of the South Carolina's coastal plain was covered by water here. And then that continued into the Miocene, the Pliocene, and then what we were talking about with the Pleistocene, when we started to enter those glacial and interglacial periods of time. And this is the last glacial maximum here. So the ice sheet was down about as far south as New Jersey. And then the Holocene is our most recent epoch. I don't know if any of y'all have heard about the Anthropocene. It's been in the news a little bit. It's been kind of a hot issue with geologists trying to figure out if we are actually in a new epoch that's characterized by human influence, microplastics, radioactivity. So is there a signature in the rock record? So I think that's still under debate. So this is a cross section of our coastal plain. So you can see here in South Carolina, the coastal plain makes up over half of the state. This is a geographic province. We also have the Piedmont up past Columbia, and then a little section of the Blue Ridge up here, adjacent to North Carolina. And if you look at this in cross section, these are all of the deposits that we find that were deposited relatively recently when our coastal plain was covered by the ocean. So up here near Columbia, we have Cretaceous deposits that could be 67 million years old, and things just get younger and younger and younger as we go towards the ocean here in this cross section. So Orangeburg Scarp, Surrey Scarp, about 1.2 million years old. So all of this is geologically Pleistocene or Holocene. So young stuff, definitely geologically really young. So South Carolina geographically is also part of what we call the South Atlantic or the South Georgia Bight. This is an area that stretches from Cape Canaveral in Florida all the way up to Cape Hatteras up here in North Carolina. And if you notice, this is in feet here, so this is the shelf break. So things are pretty shallow off of our coast until we get to the shelf break here. But you can notice it's really quite wide here, offshore of South Carolina and Georgia. If any of y'all have been to South Florida, the Gulf Stream is right there, and the shelf break is right there. So if you wanted to go off, deep sea fishing in Florida, it's much quicker to get there. Same thing with North Carolina here. So we experience a tidal range, a semi-diurnal tidal range. So we have two high tides a day, two low tides a day. And it is classified, there's a classification scheme for tides: microtidal, mesotidal, macrotidal. Up in North Carolina, they have microtidal tides. Up there, there's not a whole lot of difference between the high tide and the low tide, but here in South Carolina, as y'all know, there's quite a big difference. And then it only gets bigger going down into Georgia. And a lot of that has to do with the width of the shelf. We also have, here in South Carolina, wave height tends to increase offshore of North Carolina. Surfing is better offshore of North Carolina. Wave heights are generally bigger offshore of North Carolina, and that wave height decreases toward Georgia. The tidal range also increases with the width of the shelf. So as we go down towards Georgia, the tide range increases, and then it decreases as we go into Florida. So this is what's classified as a mixed energy system. So our barrier islands our coastal landforms are impacted by moderate waves, moderate tides. And so as a result, we get short drumstick-shaped barrier islands along the central and southern coastline of South Carolina. We also have numerous tidal flats and coastal wetlands. And one takeaway I'd love to leave y'all with is that we have complex sediment distribution patterns. So things can be very, very compartmentalized from inlet and island to inlet and island. So what's going on Kiowa could be completely different than what's going on Edisto, for example. Things can be very compartmentalized, and that affects the sand source, the orientation of the barrier island to the coastline, so multiple different factors. Another important thing is the sediment transport direction. So sand in what we call the littoral system, just offshore, tends to move from north to south in a zigzag pattern. So if you have a grain of sand on the beach here on Edisto Beach, for example, it's typically going to move up or sort of south, and then in this easterly direction, and then there's sort of a zigzag motion. So over time, sand on Edisto Beach should make it into St. Helena Sound, on the Hunting Island, Fripp Island, and so forth. Now, there are some areas along our coastline where there is a longshore transport reversal, and the sand actually goes from south to north. And the northern end of Edisto, at Old Botany Bay Island, is actually a place where that's happening. Cape Island up in Cape Romaine is another example. But in general, this is the model that tends to be what's followed and what the case is. So another coastal landform that's very important to understanding our coastal geomorphology here are tidal deltas. So if you go out on the beach, at really any of our beaches, so I go up to Folly Beach pretty regularly. If you're up on the northern end of Folly, if you're on sort of the northern end of Edisto, and you look out at a very low tide, you can probably see waves breaking along the tidal delta. So these are areas where sand is deposited from our inlets. So in this schematic here, Seabrook right here, this is the North Edisto, and this is Botany Bay Island. So we've got Edisto down here. Ebb tidal delta, we have ebb tidal deltas here in South Carolina because our ebb tide tends to be a little bit faster than our flood tide. So water floods in, and then it takes less time for it to come back out. So the currents tend to be faster on the ebb tide, and that means they carry sediment with them. So that sediment gets deposited where it meets that longshore current that's running in this direction. So as a result, you can see these lighter colors here. DeVoe Bank would be roughly around here, and we have just a huge deposits of sand in our ebb tidal deltas. So you can think of it kind of like a bank almost. The sand is deposited there, and from there it's distributed onto the islands. But each ebb tidal delta has a different morphology or shape to it, and that is going to impact erosion on the adjacent islands. It's going to impact sediment delivery onto those islands as well. So just as an example of the volumes of sand that ebb tidal deltas can hold, it's estimated that they hold about 77% of the total volume of sand along our coastline. And in the North Edisto, it has an estimated 230 million cubic yards of sand in it. So just to put that in reference, a large beach renourishment project is about 1 million to 2.5 million cubic yards of sand. So massive amount of sand. This is a big factor in discussing and understanding why our islands act the way that they do. Not all areas have tidal deltas, actually. North Carolina has flood tidal deltas, so it's sort of the opposite of the situation where the sand gets pushed in on the flood tide. So kind of an opposite. What happens is that in many cases, at least, downdrift beaches are nourished through a process that's known as sediment bypassing. So we talked about tides and waves. tides and waves are both really important to sediment delivery and to shaping the sand that's in these ebb-tidal deltas into bars, into big sandbars. Most of the year, our waves tend to originate out of the northeast. So those waves are going to push on this sand and push it closer to shore. And this is an image, an aerial of Capers Island north of Charleston, and it's kind of a funky picture because north is actually in this direction here. So we're looking at, this is Bull Island right here, Capers Island, Louise is right down here. This is the ebb tidal delta at the mouth of Price Inlet here. And so what happens over time is that the waves push on the sand in this delta, and that sand will tend to attach here to the northern ends of the islands. Sometimes, so this is the main channel here, sometimes we do get a marginal channel right along, usually forms really close to shore, and so when you hear about erosion happening at, say, the northern end of the Isle of Palms, usually it's because there's a shoal attaching and it's pushing sand here and then it's funneling water right here. So sometimes there can be localized erosion temporarily until that sand actually makes it onto the beach. Historically, ebb-tidal deltas were how we get renourished, our beaches are renourished naturally. They were also a navigation challenge for people in the 1700s and 1800s. There actually used to be an ebb-tidal delta at the mouth of Charleston Harbor. The harbor was naturally only about 12 to 15 feet deep, which is pretty hard to imagine since they most recently dredged it to about 50 feet deep. But if you had a ship and you were trying to sail into Charleston Harbor, you would actually come in kind of parallel. You would come in around Folly, modern day Folly Beach, and you would sort of hug it parallel to the coast here and then into the harbor. But of course, shipwrecks were a big issue back in those days. But in terms of geomorphology and sand distribution at tidal deltas, this is a massive delta that also kind of buffered Folly and Morris Islands as well. So the Charleston Harbor jetties were put in place in the late 1800s to keep the mouth of the harbor open, and so as a result they interrupted this flow of sand from north to south here. And if any of y'all are familiar with Folly Beach, I'm sure y'all know there are episodic periodic renourishments. They have a 50-year agreement with the Army Corps of Engineers, and much of that is due to the jetties having been put in place in the late 1800s. So here is a picture of here's Morris Island right here, so the harbor is right around here. Here's Folly Beach, and you can see Lighthouse Inlet here, and then this is the Morris Island Lighthouse. So the Morris Island Lighthouse is a great example of how the coast can basically move underneath a stable, stationary object. The lighthouse was built in 1876. It was actually built about 2,700 feet onshore. So shoreline would have been probably way out here. By 1938, it was at the water's edge, and that island was basically just rotting out underneath that lighthouse. And then, of course, present day, y'all know the lighthouse is out in the water. But yeah, some of the questions that we ask in this case is, where is the sand coming from? Also, what engineered structures are in place? In this area, we have the jetties just north of Morris Island. And then down here on Folly, there are also structures called groins, which I know Edisto Beach has groin field as well. So these are engineered structures that are used to trap sand. Of course, beach renourishment is another soft engineering technique that is used very, very commonly in South Carolina. So Folly Beach is a great example of a transgressive or a landward moving shoreline. Another example would be Pocky Island at Bonny Bay. We do have certain indicators of a transgressive shoreline. So when the sand is being pushed back towards land, we often see boneyard beach and washover deposits. So this was taken out at Botany Bay at Pocky, where I'm sure y'all are all familiar with the beach out at Pocky. This area used to be a maritime forest, and the erosion has pushed the shoreline back into that old landscape, and these trees are a remnant of that old landscape. Washover deposits, this is a washover fan on the south end of Folly Beach at the county park. So these are common on islands where you don't have maybe a stable dune system to absorb energy from high tides or from storms. So what happens is that sand from the front of the beach will actually wash over into the marsh and cover it up, which is, we see this sometimes in cores that we take. Sometimes you'll see marsh sediment, and then you'll have a layer of sand on top, and sometimes it's a washover deposit. Also, older marsh deposits outcropping on the beach, so similar to the boneyard beach. This is older geology being eroded into and then exposed. And so out at Pocky, I'll talk more about that in a minute, but we've done a lot of work out there because people, of course, come to the beach, they see something like this. They see the cemented sands, they see the orange kind of pools of water, and they think, I've never seen a beach like this. But it is an indicator of a transgressive early and lagoon shoreline. And then sometimes we also see, this is up in Cape Romaine, in situ oyster beds, so where the shoreline has moved back into areas that used to be tidal creeks. So I'm just going to move down the coastline, and we just talked about Folly and Morris Island as being transgressive barrier islands, where the shoreline is moving back towards the mainland, and you can see here in the red, this is an 1871 shoreline here. In the blue, we've got a 1939 shoreline. And you can juxtapose that with Kiowa right here, where you actually have the modern day shoreline in the yellow out seaward of both of these lines, opposite to Folly and Morris Island. So Kiowa gets a lot of its sand naturally from the uptidal delta at the mouth of Stono Inlet here. The estimated volume on Stono Inlet is about 95 million cubic yards, so not as big as North Edisto, but it seems to be of a volume that it actually, the shoals attach fairly regularly to the northern end of Kiowa Island. So that's shown here in this picture. You've got Stono Inlet, northern end of Kiowa Island. I think this was, I can't remember when this was collected, but you can see the shoal here attaching. Waves would kind of be coming in from this direction and pushing all that sand onshore, and then the longshore transport is going to push it south through that zigzag motion. And this is another cross-section of Kiowa, where we have the modern beach right here, and we have prograding beach ridges. So we have beach ridge here, time passes, we have another beach beach ridge building towards the ocean, and then back in the back barrier, we have an area called Shulbridge Bridge that's been dated to, I think, around 5,800 years old. So back with sort of the sea level rise that happened after the last glacial maximum, we think we have age dates of about 5,800 years here. We have some others up and down the east coast for marshes that are in the realm of 6,000 to 3,000 years old. So that's the time frame where we think things became stable enough that our modern landforms were able to actually form from the sand that was collecting here at the mouths of our inlets. So Kiowa is a good example of a prograding barrier island versus a transgressive barrier island. Moving down the coast towards Edisto Beach, we have Seabrook here, which is in Captain Sam Spit here, which is they're in a lot of the coastal geology terminology. There's something called a drumstick barrier island, where the northern part of the barrier island is really thick and then it kind of thins out, and Kiowa and Isle palms are really classic examples of that. Then we have the North Edisto here and coming down to Edisto Beach, and I'll be focusing the rest of my talk on Pocky and Botany Bay, but I just wanted to show y'all, I thought y'all would appreciate this aerial photo from 1939 of Edisto Island, which is, I mean, these are, we call these, informally call these horsetails here. These are old beach ridges, so you can see the pro-grading beach ridges here. So these ridges should be older than these ridges here as the sand built out here, but it was neat to see Big Bay Creek and Scott Creek here in this aerial photo. So we have done, I work specifically on DNR coastal properties. It's kind of where I'm tasked to do actual measurements. A lot of our coastal communities, coastal towns like Hilton Head Island will have their own beach manager. They have their own group, people who collect measurements, look at aerial photography. Of course, South Carolina DHEC OCRM is the state agency that is tasked with beachfront mandates, and they are the regulatory agency. Within DNR, we are on the research end of things. We do a lot of research on our own properties, especially Botany Bay, because it is our most popular DNR property, not just coastal property, our most popular DNR property, which makes the work of volunteers and biologists who work out at Botany Bay extremely important, because there is a lot of interpretation that's needed when people come out to the beach there. But you can see that reflected in these numbers here from 2018 to 2023. 2021, of course, was a huge year. A lot of people visit the property out there. Of course, it's also a nesting beach. We're looking at sea turtles, I think ranging between 150 and 300 nests per year in the past 5 years or so. And also, it's the site of 2 known Paleo-American shell rings, one of which we've lost in 2022. It was discovered in 2016. I don't know if some of y'all were part of the excavation that happened out there in 2018. Our archaeology group did an excavation, and then it just eroded away very, very quickly. So faster than we expected. But I started working out there and going out there at least about once a month in 2017. Bess Kellett, who was the volunteer coordinator out at Botany Bay for a long time, she called me up and she said, hey, there's some stuff outcropping on the beach. We don't know what it is. We'd like for y'all to come out and take a look at it. And we went out, and this is basically what we saw, which is a familiar scene to many people, anybody who spends time out there. There is some underlying geology that tends to be uncovered and recovered. I feel like it's usually more exposed in the winter months after going out there for a few years now. But we found this iron-rich sand here, and sometimes it was right over on top of a green clay, which to us is evidence that this was a programming area at one point in its geologic past. But it's also, as we talked about, an indicator of transgression. So this is an indicator, the exposure of the geology on what we call beach, which is really just a thin veneer of sand that's being pushed back over the old island, is an indicator that this island the shoreline is eroding and re-exposing some of the old geology. So the iron here comes from minerals like magnetite, ilmenite, that were buried for a long, long time, being exposed to air, to fresh water, and I am not a chemist, but this is the chemical reaction that comes with it. We see a lot of iron staining in this sand, this cemented sand layer. We also see a lot of sort of pooling of orange water, and so a lot of this is bacterial, but it's coming from those iron-rich sands that were buried for thousands and thousands of years. So going back to, I just wanted to mention really quickly, because it's important to our shoreline work, the map that I showed y'all earlier. Another great thing, really interesting thing about Edisto, if you'll notice, this map is maybe not the most accurate map. You might not want to sail a boat in Charleston Harbor, but maybe it worked back then, I think. But Kiowa looks a little different. It was it could have used improvement, and they understood that. And so back in the early to mid 1800s, there was really the first effort to create accurate nautical charts and coastal maps of the Atlantic seaboard. And Thomas Jefferson actually kind of led the charge on this. He established the U.S. Office of Coast Survey, which became NOAA, and the National Geodetic Survey in more recent years. And they established a series of baselines along the eastern seaboard. There were 7 of them. And one of them, he was here on Edisto, which is pretty remarkable. There's actually a marker here at the Environmental Learning Center, and then there's another one up at the Botany Bay property. These are granite markers. They say U.S. Coast Survey on them, and they mark the start, and actually I think this was the start and the finish of this almost 7-mile long line. They chose, one of the reasons they chose Edisto was because it was relatively unbroken by large tidal creeks. They needed to physically measure out a very, very long line, and they did it with 2 instruments that were called the bars of invariable length, that were made up of 2 different metals that compensated for each other in terms of their expansion rates. So amazingly, they did this survey in 1850. In the winter of 1850, they had to cut a line. They ran the survey, and NOAA went back more recently and with a GPS, a high resolution GPS, and they were only off by 2.5 inches. So it's remarkable what surveyors were able to accomplish in the 1800s. This is also actually a baseline map right here that's really nice. There were markers put along each mile. There were stones. I don't know how many of them have been recovered. I do know that the base monuments are, you can visit both of them at the Botany property, and then also here at the Environmental Learning Center. So I definitely recommend taking time to go do that, because it is a really, really fascinating part of Edisto's history. So they measured out this long, almost 7-mile baseline, and what they were able to do, they constructed towers over each of the monuments, and then they were able to use surveying equipment to shoot an angle to a church steeple that was in the distance. So they were able to, it's trigonometry, they were able to figure out the angle here, and then with those measurements, they were able to figure out the lengths of these lines of the triangle and establish new baselines. So our modern maps are based on these measurements that are triangulation, which is just, it's really, really neat. But that happened back in 1850, and then this office, the U.S. Coast Survey, proceeded to spend the next 18, 20 years working their way up and down the East Coast from these baselines. And so there was a crew here that got to know people here on Edisto. And actually they, so John Townsend was the property owner here at Botany, what's now Botany at the time. And they made him a special map, which is great for us because we want to know what the shoreline looked like back then. So we have this Best provided us with this. It was hanging on the wall at the volunteer house. And we were able to take the College of Charleston, and they scanned it in for us, and we geo-referenced it, which means we put it in the context of a modern map, and matched everything up. So the park, let's see, this is an old Botany Island. So the only thing that remains of this barrier island here, which you can see kind of looks like a drumstick barrier island, is just this northern part right here is Old Botany Island. And this is Pocky. Right here. So the parking lot where you park to go out to Pocky is, I think, right around here. So this was very useful for us because we were able to bring it into GIS software that we use. And you can see that old map here in the transparency. This is actually, they had a causeway back, and a continuation of the modern day causeway went back way out into the ocean here. So almost a half a mile. This is from 1851. So from this and also other aerial imagery, we've been able to establish different time steps for the historical shoreline. So when 1851, we know it was out here. We also have aerial imagery we collected from the Thomas Cooper Library up at the University of South Carolina, and we stepped that forward here. And this is an example of some of that older imagery. This is from 1949, black and white, and you can see, here's a transgression indicator right here. You can see a washover fan right here. So we know back in 1949 there was quite a bit of erosion going on. Right here, this is Pocky. So Pocky Island was actually a hammock island. It was not it hasn't been very long that it's actually been at the shoreline. It was a back barrier island for a very long time, and then the other island was way out here. But taking these historical shorelines, we've been able to do some calculations and come up with a rate of erosion. So this is our long-term rate of erosion, about 25 feet per year. So keep that in mind as we talk about more modern rates. So over the past several years, since about 2018, we have a biologist, Gary Sundin, who he has a drone commercial UAV license, and so he's able to fly this area, and we're able to digitize the shoreline using the orthophotos that he produces. So now we have time steps, annual time steps going back to about 2017. So you can see here, this is a digital elevation model from NOAA that was flown after Hurricane Matthew in 2016, and this is the data set that revealed the shell rings on Pocky Island. So you can kind of see sort of like a circular shape right here. This is the second shell ring. This was shell ring 1, and here in 2022 we've got the shoreline right at the back edge of that shell ring. So now we have more frequent shorelines, because during the 40s, 50s, 60s, 70s, it would have been more infrequent that they collected aerial imagery. We didn't have satellite imagery at the time. It was really the USDA collecting imagery, and they would typically do it by county. So now we can do it, multiple times a year if we need to. And so calculate, as a result of this, we can calculate short-term erosion rates. So last erosion rate we saw was 25 feet a year. If we take 2011 to 2021, it's actually almost 30 feet a year. Just taking into account 2017 to 2021, it was about 40 feet per year. So that's what call me and say, it's moved. and it did, it moved, and we were able to quantify it in this manner. But as you can see, Pocky here, and this is why all that geology is, all those layers and geologic units are exposed on the beach, is because the shoreline is eating into that underlying stratigraphy. And this is another view of where the shoreline was in 2018, where the shoreline was in 2022, where ring number 1 was, and then where ring number 2 currently is. This was made by Gary, and I mentioned that our archaeology team. I go out to Pocky monthly to. I have a series of erosion transects that I measure every month, and after particularly large king tides or any storms, our archaeologist Meg Gilliard also comes out and she measures the location of the shoreline using an RTK GPS, so high resolution GPS. And then Gary will typically come out with us as well and fly the drone. So we have kind of a multidisciplinary group that goes out there very, very regularly. This is just a picture from 2018. So this was an excavation that they did on shell ring 1. They were able to get a lot of material from that shell ring. Much of it is in Colombia now, being archived and cataloged. So you might ask yourself, why is there such a high erosion rate in this area of Edisto? So there are some publications from and some reports that were done in the 1980s, and some work that was done to kind of look at old historical nautical charts. and the location of the shoreline. And so we were talking about the ebb-tidal delta at the mouth of North Edisto and how large it is. So we think it's about 230 million cubic yards of sand. It's just, it's massive. So something that big has the ability to trap more sand. It also has the ability to direct waves in different ways. So this is DeVoe Bank right here. This is from a paper from 2004. And you can see the general direction of the water coming out of North Edisto Inlet is basically straight out into the ocean. And what we think is that this wasn't always the case. This wasn't always the main channel. Looking at old nautical charts from the 1800s, it seems like there was a switch and it directed itself straight out. The North Edisto is a deep inlet. It is about 50, could be about 50 to 60 feet deep versus 20 to 30 for Sonoma Inlet. I mean, Lighthouse Inlet is even shallower than that, so this is a very deep inlet, and that has an impact on this as well because those velocities are going to be pretty high as that water is moving out on the ebb tide. So as a result of this inlet location switch, we had more sand being deposited further offshore. Waves coming in from the northeast were actually kind of directed around this huge body of sand here. And then we have a shoreline, we have a reversal here. So you can see these little arrows right here, and these are indicative of the movement of sand along Edisto Beach. So you can see our normal sand transport direction is north to south, and that is the case for part of Edisto, for the southern part of Edisto. But here, as we get to right around the central part of Edisto, right around Jeremy Inlet, there's actually a reversal. So the sand is moving north. There is some sand that's being deposited on the northern end of Botany Bay Island. But it's really just, it's not staying in place here. It's not building up. There's not enough sand staying around long enough to establish dune systems, which are protective in the instance of high water and storms. So we have a few different things going on. We have waves being refracted around the ebb-tidal delta. We also have this ebb-tidal delta kind of acting like a natural groin and capturing a lot of the sand that's moving south here from Kiowa and Seabrook. And then we also have erosive energy from waves impacting the beach directly, which we've definitely seen out at Pocky being a factor in the erosion out there. So I'm going to show you this is just a short video clip from, it's called Google Earth Engine Time Lapse. If any of y'all have, this is a really great resource for looking at land cover, land use changes, but also coastal geology and geomorphology. This is compiled satellite imagery. It's called Landsat imagery. So it's NASA and USGS imagery starting from 1984. It's 30-meter resolution, so you can't zoom in to like a house level, but it will give you enough of a resolution so that you can see kind of wider changes. So this particular video goes from 1984 through to 2018. So I'm going to play it, and it'll play through 3 times. So to orient you here, we've got the North Edisto, we've got Seabrook, DeVoe Bank, Botany Bay Island, and then Pocky is right here. Keep an eye on DeVoe Bank, the northern end of Botany here, and then also Pocky. Let's see. There we go. So it's going through the 90s right now, early 2000s. One more time. So what are some things that y'all notice?
It looks like the bank is actually, well, bank's actually moving.
DeVoe, yes.
It's like moving,
Yes.
building, but it's moving at the same time.
Yes, yeah.
See, I've experienced with my own eyes the shifting of DeVoe, but this is more, what's more dramatic to me is the coastal inland Pocky, because that's something, you can kind of see it, but you don't see the regression without this as much, whereas DeVoe, every time you go there twice a year, it's like shifted, so.
Yeah.
So that's pretty fascinating. And do you think that's gonna continue? It's gonna continue to push things inward?
For DeVoe
For Pocky?
right here.
Well, DeVoe, who knows what's, I mean, it's gonna continue
Yeah.
to morph, but I'm just more interested in Pocky and where it's going.
I think, I mean, we've seen such a linear rate.
Yeah, it's just
I
gonna
mean,
keep
it just
pushing it.
keeps push. Some shorelines you see it moves back, it moves forward, it moves back, it moves forward. But it's very, very clear. It's very easy to generate an erosion rate of Pocky because it just moves straight back. So unless something changes with the sediment supply or the dynamics going on here with the inlet channel, I think it's going to continue. But something could change with the sediment dynamics or the outlet because it has in the past.
With the, you know, that DeVoe bank forms, squeezes that off, I could create a more of a funnel for that water to come out and actually
Yes.
increase the rate of erosion on Pocky.
That is exactly right. Yep, that's what we see at northern ends of several other barrier islands too. You get that sort of marginal channel. And I would love to have an instrument to set out here and see what kind of velocities that water is running compared to the
Having
water
swum right
straight out.
between those many times, and sometimes you can touch and sometimes you can't, and yeah, the velocity of water that's coming through
I bet
is
it's
intense.
intense.
Is the brightness of the beach indicative of overwash? Or the color becomes brighter? Is
Yes.
that the amount of overwash that makes it bright?
Yes, that is correct. Yeah, because that's new sand being pushed back, and it's going to be brighter when it's pushed back regularly, because the washover fans and terraces are usually recolonized by vegetation. But that's a really good observation. It's really bright white, so that means there's pretty continual overwash. Vegetation doesn't really have a chance to establish.
I heard recently that the DeVoe is starting to kind of fall apart, parts of it.
Yeah.
Do you have any information on that?
It's a cyclic feature. So it forms, it gets close to shore. I am not sure if it attaches in the same way that a shoal attaches to, say, the northern end of Kiowa or not, or if waves just overtop it and then disperse that sand. But it is a feature that's associated with that ebb tidal delta. So you can think of it as just like an emergent shoal that's above the water line. But it disappeared after Hurricane David in 1979, and then it reformed. So let me play this again. Let's see if I can play this again. So 1984, you can see it's just kind of like a thin, almost teardrop shape. And then the horseshoe shape is really distinctive, but we think it's because there's a current reversal here, and the currents are moving north and kind of pushing it into this horseshoe shape, versus it being more of like a elongate shape. But it starts as kind of a sandbar elongate shape. But let me skip ahead. Oh no! So this is a view of DeVoe in 1989. This is a month after Hurricane Hugo. So you can see at the time, Botany Bay Island was actually, there was an inlet right here. So it was separated from this area here. Here's Pocky. So Pocky was still not at the shoreline. You can see that really bright white. This is 89. Today, this is from map data to 2024. I just took this, captured this from Google Maps. This is where, here's Botany Bay Island right here. Here's DeVoe Bank. And then here is sort of, I call this sort of proto-DeVoe, because they're kind of both the same thing now. This is right where this version of DeVoe formed in the early 1980s. So, and what's neat is that we also see a horseshoe-shaped feature on the old charts from the 1860s. Very distinctive. That crew, the Coast Survey crew, they actually came out onto DeVoe and they occupied it and they used it as one of their triangulation points. So we know that, y'all saw the old map, we know from the maps from the mid to late 1800s that DeVoe was around like that. But I know from people telling me, oh, I was on DeVoe as a child in the 1950s and it was huge and there were trees on it, and then we know we have some great record since the 1970s and 1980s of satellite imagery, so we know it develops moves closer to shore, and then it redevelops back where it started from. So it's just a really neat feature, but it is, I consider it part of this ebb tidal delta complex here, and an indicator of how much sand is in that ebb tidal delta. It's pretty incredible that, you know, a feature like this is able to become vegetated at some points in its evolution. But yeah, I'm watching it closely because it also has implications for, you know, all this part of the shoreline, possibly increasing erosion right around here. But, you know, does that sediment get delivered to the beach eventually? That's something that we're really interested in tracking at Pocky. Yes.
Do you think the Bow Bank will close up the channel eventually, and eventually is when it will be?
I don't know. We need better data on that because I'm not sure how deep this is, what the currents are like. And I mean, just the fact that we have this massive ebb tidal delta tells me that the currents, the water velocity is high, and that sand may not hang around here for very long, but where it gets distributed to, I think is a big open-ended question. But we do know that it's being pushed onshore. A lot of that is because of waves. And that we do have a new feature forming here. But that's something I hope to answer in the next couple of years. Yeah.
Cindy, have y'all had a chance to start looking at the impact of the 2 storms last winter? Because we see right here on Edisto major changes on the beach. Have y'all started looking at those?
When we go out and we collect our monthly measurements, we are able to see sort of in real time how far back it's moved. And on a couple of occasions, it's been, 15 feet lost after, especially that nor'easter. December was really, really something. It actually, I don't think I have a picture of it, but the erosion transects that I'm using as part of our collaborative study with archaeology and Gary, who's using a drone. Gary's using a drone map. Meg with archaeology is using a high accuracy GPS, and I am using an on-the-ground transect method that's just steel rods that are placed in the ground, run a measuring tape past them, actually, I'm going to tell you all about an opportunity. If anyone is interested in learning how to do that, or being part of a volunteer network out at Pocky, Meg is working on her PhD, and I have a handout, and she is going to be establishing a volunteer group to go out and measure the transects more often. But I installed the original array in 2021. There were 5 transects. There were 2 sort of steel rod benchmarks per transect, and they were completely wiped out by that nor'easter. They were totally wiped out. So we reestablished everything in March, and we had to put everything back. And some of the poles are in the marsh now, behind Pocky, because we were thinking, okay, is 150 meters enough to get us 10 years? We hope so, but it's difficult to.
I was in Jeremy Inlet today, and I had never seen it look like it looks like now.
Really?
Yeah, I mean, I know it changes all the time, but there's more sand in there than there has been in the longest time.
Interesting.
Yeah. And yet we've lost so much on the front beach of the park.
Yes. And as DeVoe gets closer to shore, I mean, you may observe sand in surprising places, but how long it stays is another thing. Yes.
I have a question about time.
Yeah.
Sea level rise is driving the inward migration of the water. So for the folks building the retaining wall on Isle Palms.
Yeah. Well, the wall. So a seawall is. Let me jump ahead here a second because I have a picture of a seawall. A seawall is a coastal engineering device. It's used, we saw some groins and jetties earlier, and seawalls are built shore perpendicular. So they are supposed to have a protective element to them. The purpose of a seawall is just to protect the property behind it. So, but, this is out at Folly, where it's difficult. The sediment source is not what, what other places have, and so they're using this to protect this property. I'd say dunes are the natural way of doing this, of having some shoreline erosion protection. One thing about seawalls is that they scour out at the toe. So what happens is that this is a normal profile of the beach here, when you have a seawall here, the wave energy is going to hit the seawall and be directed downwards. So often you have scour. That's why people put out riprap at the base of their seawalls, is to dampen that, trying to dampen that energy. But I mean, that is an interesting case, and it's getting into regulatory land for sure, because we don't know what's going to happen with that case. But I would say anytime you can build dunes, that is going to be a plus. That's something that I showed y'all a washover fan at the southern end of Folly Beach. And the county park there they built a very long groin. They also built dunes there, and it's had a big protective element. I don't think they've had a washover event like the one that I showed you in that picture. So putting energy into dunes is great. But it's also a matter, you mentioned sea level rise, it's also a matter, each case is a matter of where's the sand coming from, how much sand is there, because if there's enough sand, a beach can continue building out. Kiowa, for example, is doing, is doing very well. It's prograding, and that sediment source is very reliable for them. So it's very much a case-by-case basis, and based on what's going on at the Paddle Delta and the inlet that's adjacent. Yeah.
On Huntingsville Beach, we built numerous sand dunes and planted grasses on them, but the storms are so frequent.
Yeah.
They wipe them out before they get established. Do you have any advice?
I'm sure, we are dealing with the same thing in Pocky, and trying to, although Pocky will not be, it won't be renourished. We won't put any erosion control devices, at least none that I'm aware of, but we see the same thing. And that's something that we are investigating right now, is the higher incidence of hate tides is really, it's not necessarily the storms that are pushing the beach back, it's also the heat tide events that are really seeing the high water events pushing the shoreline back. So I mentioned that the town of Kiowa Island, they're getting really serious about resilience right now. And the town of Kiowa Island, and I mentioned to Melinda, Lee Bundrick, who works for the Kiowa Island Conservancy there, he put together a report assessing all the resources as they are right now. They have a shallow groundwater monitoring network, and they're working with homeowners on strategies. So I think that would be a great potential resource for y'all, for someone who can say, on a property by property basis, here's some things that are working for us. It is a different part of the compartment, but yeah, I think there are more coast communities coming together and trying to come up with some solutions, because that's a good point. In some instances, as I've seen directly out of Pocky, I can't keep those poles in the ground, and they're completely wiped out. So there's nothing that we are doing to try and stabilize the shoreline, but that is a topic of conversation, I think, amongst a lot of coastal communities and coastal managers.
How would we get in touch with that person?
I will.
Yeah, we're going to go ahead and do that. We have a new environmental committee at the Land Trust, and they're going to be working very closely on some of these topics. And again, your neighborhood could probably, benefit from that. But that's something that we will bring in, whether it's through the Ed Outreach or the environmental committee, because it is so important to all of us. And if they've already invented the wheel, so to speak, we can all learn from them. And we're right next door, so I think we need to engage those folks.
Yeah.
Would you please comment on the report I read about the fact that New York City is subsiding rapidly, maybe due to delay effects from glacial activity and maybe the building of heavy buildings, but they also commented that the coastline where we are is subsiding rapidly as well. What comments do you have about that relative to what's happening to Edisto?
Well, connected to what you're asking, we're also looking at land sinking because we're siphoning off so much water. So it's sea level rise and land.
So sorry, but what is causing that? Is it our tremendous coastal sedimentary sinking, or is it our water removal? What's causing subsiding?
In some locations, it's related to water withdrawal from the aquifer. As you were saying, this has been something that's been going on in California, for example, for a long time because they're taking so much water out of the ground. And if you think about the pore spaces and some of those aquifers, being buffered and filled with water, and then that water being gone, the pore spaces will collapse and those grains will kind of come, touch each other. So that is one factor in some locations where you have over withdrawal of groundwater. But more regionally, there's been a lot of recent publications and some work recently by Virginia Tech University looking at some data called INSAR data. So it's interferometric, I might get this wrong, aperture radar, but it's satellite direct. And they're able to take data sets over time and compare the ground level and see what the vertical displacement is. And just tectonically, we are in a natural, we call it low country for a reason. There is what we call the Cape Fear Arch. So we have kind of a high up near the North Carolina border, and then we have kind of a tectonic, kind of a lower point here moving towards Georgia. So we are now seeing some natural subsidence as well, on the order of likely at least a few millimeters per year. A place where it's a huge concern is Louisiana, where they have had a lot of oil and gas withdrawal. Also, sedimentation from Mississippi is not historically what it once was. So we have an ongoing project in salt marshes where we're looking at whether our marshes are keeping up with sea level rise. Subsidence is part of that conversation as well, because if the whole ground surface is sinking down, then that's going to make the effect of sea level rise. It's going to amplify things. It's going to make it harder for the land surface to sort of keep up with it. Part of it is also related to glacial-isostatic rebound, which is going back to that giant ice sheet I showed y'all. So that thing is, of course, immeasurably heavy. Continental crust is pretty buoyant. So we have, globally, we have continental crust, we have oceanic crust. Oceanic crust tends to be made of minerals that are heavier, and there's a lot of quartz, a lot of silica in continental crust, so it tends to be more buoyant. But when you put a huge ice sheet on it, it actually kind of lowers it. So there is an effect still ongoing, and that is really interesting research because people are doing a lot of modeling work trying to understand how the crust is responding to that ice sheet having retreated. So in places like the Northeast, you actually may have the crust, the continent moving upwards relative to sea level versus moving down. But I would say subsidence is something that happens. From the data that I've seen, it seems like there's multiple data sets that are showing that there is some subsidence in our area. It's on the millimeter scale, and I can't speak to New York, and I know the built environment, having all those buildings on the peninsula has to have some kind of an impact. But there is a natural subsidence signal, vertical and motion signal. Yeah. Did that answer your question? Okay. So let me see. Just going to mention some ongoing work that we have out at Pocky. We had a coring project back in 2019 where we collected. So here's the 2022 shoreline here. At the time, Shelving 1 was still mostly visible, and they were doing an excavation out there. So we collected a core here, one a little bit further back, and then one along the causeway and one along this small hammock island behind Pocky here. So our objectives were to look at the stratigraphy or the underlying geology, and also to get some material that we could send out for age dating to get an idea of how old Pocky might be. And I've got the upper part of core number 2 up here, if any of y'all want to take a look at it. This part is mostly sand, but I have a log here too, and further down it turns into estuarine clay. So we were able to date some of the sand, and the dates came back to about 50,000, 60,000 years old. So a lot older than I showed y'all. Kiowa was about 5,800 years old. So Pocky is quite an old island. The shell ring has been dated to 4,300 years old, just for context.
So, with your line, could you please show me Pocky Island?
Yes.
The exact.
So this is Pocky Island right here. This right here.
Okay, what is that inlet?
This right here.
That's the Pentagon.
This is the hammock. Have you walked out to?
Following the ocean, right there, what's that?
This is a washover fan.
Oh, okay.
This is a washover
I'm
fan
just
right
trying to
here.
figure out how far up Botany we're going from Pocky Island.
Okay. Yeah, it's probably right around here, I think.
Okay, so it's a big area.
It's a big area.
Okay.
Yes,
Thank
yeah. Yeah, absolutely. And if you go out there, the beach parking lot is right about here. These sediments here on what we would call the mainland have been dated to about 80,000 to 100,000 years old. So this is actually quite an old feature. We think it was probably stranded, between marsh for a long time. But when you go out there and you see these sediments outcropping, they're very old. They're thousands and thousands of years old. So quite a bit older than some of the features that you see on Cook's Island, for example. So I've got the core up here if anybody wants to take a closer look. This is a vibra core, so this is a tool that we use, and it's just a 3-inch aluminum pipe that's, we have a generator, and we drive this down. This one went down about 12 feet, but it gives us great information about what's below the surface. Again, I mentioned the increase in the high tide events and the king tides. This is a really good resource if you want to keep track of it. It's a City of Charleston local tide trends, and they measure and record instances at which there's a flood risk for the City of Charleston, and they quantify that as being tides over 7 feet. So what's been really interesting, as we all know, things really kind of changed in 2015, 2016 with Hurricane Joaquin. We had a storm really about every single year. And this number, the hours of flood risk, has been very, very high. Just as a frame of reference, NOAA calculated the total hours of flood risk for 1954. I think it was 4 hours versus 165.9. So our high water events are really, we think, having an impact on our shorelines, and that's something that we're also trying to quantify.
So what is causing that? Do you know what's causing the increase in the king tides?
In the king tides? I mean, it's partially sea level rise. It's just, I think NOAA is, they came out with a report a couple of years ago, and they would be the people to answer that question, because it has to relate to I think meteorology as well as the water coming up, which we know it has. In Charleston Harbor, at least, there's that long-term tide gauge. It's recorded tide levels for over 100 years, and we know, for example, that it rose about a foot over the course of the 1900s. I work out at Fort Johnson on James Island, and we have historical records of a community that was actually out in what's now a marsh. And so that whole area has evolved over recent historic time. Yes?
To answer your question, one of the hypotheses is that the global warming is slowing the Gulf Stream.
Oh,
And
okay.
as a consequence of that, there's all sorts of other kind of secondary effects.
And more northeast tide winds. I feel it too.
Yes, yeah, we have some meteorologists as well that we work with at DNR. They have a station out at Botany Bay, and it does seem to be the onshore winds do tend to hold tide in. Now, sometimes you'll look at a predicted tide, and we'll go out there for field work and we'll say, oh my gosh, this is so much higher, or the tide doesn't ebb when we thought it was going to. And so in some cases, I think an onshore wind is building that up. Yeah. I'm gonna end there, but I did have a couple of slides that I wanted to mention this. So my colleague Meg Gilliard, who works for South Carolina DNR Archaeology, is doing a heritage at risk survey and interviews and seeking public participation. There's an online survey about cultural resources, what they mean to you, and what the potential loss of these resources means to you. And I think it's, let's see, there's a link for the survey on the back of this handout. She's also doing in-person interviews at Botany Bay and at Fort Frederick. Have any of y'all been down to Fort Frederick or Port Royal? And she's going to be doing this over the summer. She's going to be at Botany Bay from Sunday, May 19th through Saturday, May 25th. And I think there will be some tents around the beach parking area, but please come take a flyer if you're interested in participating. She's definitely wants to hear from the local community about what the shoreline change, the erosion, what it means to people culturally. Another thing, with that, I'd like to acknowledge my coworkers, as well as people who have helped with the erosion transect measuring and finding aerial imagery and GIS. And thank you all for having me. And there were a few questions I wanted to pose to y'all while I have local experts in the room. If anyone has insight into any of these questions, I'd love to talk with you. I'd love to email with you. This is something I've been trying to track down for a while. We do not know why DeVoe is named DeVoe or who it could be named after. I spoke with Sam Librand at an event a few years ago, and I need to get back in touch with him because he had an idea. But if anyone knows who it could have been named after, because I assume it was named after a specific person, we would really love to know, just from a historical standpoint. It's really interesting looking back at the old NOAA charts.
Have you talked to the Gullah Geechee people? Because it might have come about.
That's a good point.
You know, and the book by Dana Beach about DeVoe Bank could have that. I didn't think to look in there. You didn't find it?
I did not find it in there because I have a copy of it, and I love that book. And I didn't. Well, maybe I should reach out to him too.
Yeah, reach out to Dana.
It's
Because he did a lot of study of that.